I would now like to introduce you to the use of the UT9000 in practice. Now let's start with the passive line location. Here, no generator is required, but existing fields are used instead. 3 different frequency ranges are available. Radio signals in the VLF range, 50 Hz at live cables, 100 Hz at cathodically protected lines. First of all, I would like to show you how to detect lines in location mode radio. Switch on the receiver UT9000 and hold it vertically. Select the location mode radio. Set the gain to about 100 dB. Select the medium volume for the acoustic signal. Rotate the UT9000 with the third parallel to your foot and hold the receiver easily in your hand. Now walk through the area of interest in a wide arc. If you cross a line, you will recognize a conclusive signal by the fact that the sound is heard and the numeric value increase. After crossing the line, the numeric value decreases again. Now go back to the point where the measured field strength is highest. If the value 99.9 is displayed at this point, reduce the gain, in our case to about 80 dB. Now slowly move the UT9000 back and forth. You see the measured field strength values increasing and decreasing. Make sure to hold the receiver as vertical as possible during location. Find the position of the highest field strength and mark this point if necessary. Now slowly turn the receiver around its long axis. The field strength slowly decreases and then increases again. This method allows you to roughly estimate the direction of the line. The located line trends towards the direction shown. You can now follow the line. To do so, hold the receiver perpendicular to the locating direction and move the UT9000 slowly from right to left in front of you. You will repeatedly see how you locate a maximum field strength above the line and you will hear an acoustic signal. If necessary, mark the route at regular intervals. Now let's have a look at how to locate live cables with the UT9000. Please note that an applied voltage on the cable is not sufficient. A current must flow. This is especially important when locating live cables to buildings or when locating street lighting cables. Switch on the UT9000 and select the locating mode current. Select the frequency of your network as locating frequency. In our example, 50 Hz. Select a maximum wide as signal behavior. Set the gain to 75 dB. The general procedure is now the same as for locating radio signals. However, in this case the display of the UT9000 shows a compass view. A line symbolizes the direction of the route. Arrows will guide you to the line you are looking for if you are close to a live cable. If you have crossed the line, the arrow changes direction. The acoustic signal increases and is highest at the point of the strongest signal. If the field strength shows 99.9, reduce the gain. In this case to about 60 dB. The field strength now increases significantly towards the line and decreases on both sides. Directly above the line you will see a diamond instead of the arrows. Lower the UT9000 to the surface at the location of the strongest signal. In the upper right corner of the display you will now see the depth of the line and the calculated current. The signal and the measured values are in permanent motion. This is because the signal is directly dependent on the load of the cable. If you want to follow the line, we recommend to change the signal behavior to minimum or to maximum narrow. After such change, we adjust the gain according to the new situation. Align the UT9000 in such manner that the line inside of the compass points towards the direction of your movement and follow the route. Mark the position of the line if necessary. When locating cathodically protected pipes, proceed as if locating live cables, but select 100 Hz as the locating frequency. This corresponds to the usual frequency of a cathodic protection current. Passive line location with the UT9000. Easy, always efficient.